Greetings to all the examination candidates out there. In this particular presentation, we are looking at part 2 of GCE O level 2020, paper 2. It is very important that before you start answering a question, you consider the time that you should spend on each question. If a question is too difficult, it's better to move to another one, and you can come back to this question in a later time. All right, so we begin with this section B, which reads: 3 friends, Mike, Pete, and John, bought a plot for 2.8 million from a man who agreed to be paid 65% of its value as initial deposit. Before we go ahead, let me remind you, it is very important that you have this question paper in your hand and you solve along or talk along. So the first thing to calculate here is the initial deposit. Initial deposit. And from the question, we are being told that this man requires 65%. 65%. And the amount to be paid in total is 2.8 million. So the initial deposit, I, will be given by 65% of 2.8 million. And when we simplify, you have a value of 1,820,000 FCFA. Now, the paragraph introduces us to the B part of the question. The deposit is paid by Mike, Peter, and John in the ratio 5:3:2, respectively. Here, respectively means the first name they have mentioned matches with the first number. That is, Mike is 5, Peter is 3, and John is 2. So if you calculate the amount paid by Peter using that ratio. So Peter's share, for Peter, we are going to have, Peter pays 3 out of a total of how many parts? We have 5 plus 3 plus 2 times this initial deposit that is to be paid, 1,820,000. And when we simplify this, our result will be 546,000 francs. 546,000 francs. Now, the next paragraph introduces us to the C part. Given that 91,000 francs is to be paid as processing fee for the documents, find the percentage of the initial deposit needed to process the documents. Find the percentage of the initial deposit that is needed to process the documents. Normally, the initial deposit we have here is 1.82 million, and this processing fee is 91,000. So this percentage will be given by, that is the C part, 91,000 divided by 1.82 million times 100% all over 1. And we'll simplify this and it will give us 5%. 5%. The D part of the question, calculate the balance expected to be paid to the man. To calculate the balance expected to be paid to the man. After this 1.82 million has been paid, the remainder from that 2.8 million that should be paid to that plot is the balance. So our balance here will be given by balance is equal to 2.8 million minus 1,820,000. And when we subtract this, it will give us 980,000 francs. $980,000. Okay. Now the second part of question 1 reads, we are given the matrix M with coordinates 4, 5, 2, 3. And the A part of the equation says we should find the determinant of that matrix. So our det M will be equal to the product of the leading diagonal. Here the leading diagonal is 4, 3. Let me indicate so that you can see this element here is the leading diagonal. So the product of that leading diagonal minus, so we have 4 times 3, minus the product of the off diagonal. It's very important to use brackets like this in case you have negative signs. 2 times 5. So this gives us 12 minus 10, which is equal to 2. So the determinant of this matrix is 2. The adjugate of this matrix be the adjugate, that's HM. To get the adjugate of the matrix, we just have to, the first thing is to swap the leading diagonal entries. So instead of having 4, 3, the leading diagonal, I'll have 3 here and 4. You swap the leading diagonal entries, then you change the signs in front of the off diagonal entries. So if the number is like this number here is positive 5, it now becomes minus 5. Here is plus 2, it now becomes minus 2. However, if it was negative, it now becomes positive. So this is the adjugate of this matrix. And in C, we have to look for the inverse. M inverse is given by 1 over det M times HM. The adjugate of this matrix, which we already have, and the determinant is already there. So our inverse is finally given by M inverse equal to 1. Our determinant was 2. Then our adjugate, what's our adjugate? Okay, we have 3 minus 5. And we have minus 2, 4. Minus 2, 4. When you simplify this, we'll have multiply each of the entries by a half. So we'll have 3 on 2, a half times minus 5, minus 5 on 2, a half times minus 2, minus 1, a half times 4, 2. So this is our inverse matrix. This brings us to question 2, and recall you can actually have this paper from our sites www.gcemathspanel.blogspot.com. Equally, if you have proposals or if you have guides for other papers, you can actually send to Gmail so that other students can equally have access to material, especially those in remote areas which are difficult to be accessible. Question 2. The scores of 20 students in a physics test are recorded as follows. So those scores are recorded as follows. Those scores, we have 70, 80, 78, and so on. So the first thing we are to do here is to represent the above scores on a frequency distribution table. to represent these scores on a frequency distribution table. Well, I would like to copy out these scores again. I'd like to copy out these scores. We have 70, we have 80, we have 78, we have 98, 84, 67, 98, 70, 80, 100, 87, 83, 70, 88, 91, 70, 78, 88, and another 88. So when you look at these scores, the smallest score here is 67. So to make a frequency distribution table, we have X, and then we have the various scores that are required. The frequencies here. The frequency. So the smallest score, let's start with the first one. Smallest score is 67. 67 appears just once, so 67 once. The next score is 70. I think that's the next big one, right? The next score is 70, so we have 70. 70 occurs how many times? Let us count. We have 70 here, 72, 73 times, 74 times. I think you have 74 times. Don't know what is 74 times, or actually 5 times. So 1, 2, 3, 4, 5. We have 75 times. I think I omitted one when counting. So it occurs 5 times. 70 occurs 5 times. The next one is 78. And 78 occurs. It can now use a different way to represent it. Like the first one I used a triangle, second one I used a circle, and now I can use an X for 78. 78 occurs 1, 2. Okay, 78 occurs just twice, occurs 2 times, and we will do like that for all the scores, and then we obtain exactly what we have. So at the end of all of this, we will have a table that looks as follows. So we have score X, then we have the frequency F, so 67, we have 70, 78, 80, 83, 84, 87, 88, 91, 98, and 100. So this is what we have, and 100. You can continue to partition. Yeah, I'm sorry, this one is actually taking a bit of time, but it's important. So for the frequencies, we have 1, 5, 2, 2, 1, 1, 1, 3. We have 1, 2, and 1. Then the next thing, the next question says, we should find the mode of the distribution. To find the mode of this distribution. So the mode. Now the mode is that value with the highest frequency. Let us look at our table. You see that the highest frequency is 5. It means that the number that occurs highest is 70. This therefore means that our mode will be 70. Our mode is 70, not 5. 5 tells us where the answer is, but the mode is not 5, it is actually 70. Then to find the median score, you have to look for the median score. For the median, when you look at all of these scores that you have on this table, at the end there, you see that the summation, the total number of scores we have is equal to 20. There are 20 of these scores that we have. Now the median of 20, when you divide 20 by 2, we have 10. So there will be 10 on the left hand side, 10 on the right hand side. So the median occurs between the 10th number and the 11th number, such that there are 10 numbers to the right and 10 numbers to the left. But in this case, you see that there is no number at that position. In between 10 and 11, there is no number. So for us to get the median, we will take the number that occurs at the 10th position and the number that occurs at the 11th position and get their average. So from our table here, when we start adding, we see that from this point we have 1 plus 5, 6, 6 plus 2, 8, plus 2, 10th. So the 10th number occurs at 80. So we have 80. At the 10th position, we have 80. And from the 11th position, we have 83. So at the 11th position, we have 83. We divide this by 2. And that will give us the median to be equal to 81.9. So our median here is 81.9. Now the next thing they want us to look for is to find the mean score. To find the mean score. For us to get the mean score, it will be good for us to complete this table, because the mean is given by the summation of each score times its frequency. So x times f. I'm going to add another column here. X times f. Normally I prefer to do it vertically, but due to space constraints I have to do it horizontally. So 67 times 1, 67. 70 times 5, 350. 78 times 2, 156. 80 times 2, 160. 83 times 1, 83. 84 times 1, 84. Here 87. Here 264. Here 91. Here 196. And here 100. Now we have to sum all of this. When we sum all, we will have the summation of each score times the frequency. The sum of all of that will give us 1,638. 1,638. All right, let me move to the next page. So from this value, we can now obtain our mean using the formula. So our mean, x bar, will be given by the summation of all each score times its frequency divided by the sum of frequency. And this gives us a value of 1,638 divided by 20. The value will be equal to one calculator. That gives us 81.9. That's our mean, 81.9. All right, the second part of question 2 concerns a straight line L1 that passes through the points P3, P4, P3 with coordinates 3, 4 and cure 1, minus 2, and meets the y-axis at the point R to determine the equation of the line 1. To determine the equation of this line. Well, we can just apply the formula directly, since we have been given the 2 points, to find the equation of this line. We have the points P34 with coordinates 3, 4, and you equally have the point Q, coordinate 1 minus 2. So I'll show you two ways in which you can answer this particular question. Two different ways which students can use to answer this question. So you can use the formula directly, where the equation of line is given by y is equal to m into x minus x1 plus y1, where in this particular case m is the gradient and the points x1 y1 can either be the point Q or P. So let me take P to be my x1 y1. Like, it's better to always run away from negative signs because most students always make mistakes and they forget some things. So I prefer to use my P. No matter which point you use, you have the same value because it's the same line, so don't be bothered. So our gradient m is given by change in y over change in x, that is y2 minus y1 on x2 minus x1. So this one can be my point x1 y1 and this one x2 y2. So my gradient will be minus 2 minus 4, that is change in y, over change in x, that's x2 minus x1, give me 1 minus 3. So this gradient will give me minus 2 minus 4 minus 6 divided by minus 2. So the gradient of this line is minus 6 over minus 2, which is plus 3. So my equation can now be written as 3 into x minus, I'm taking the points P as my x1 y1. So my x1 will be 3 plus y1 will be 4. That's the equation of the line, but you can further expand and simplify. 3 times x give us 3x. 3 times minus 3 minus 9, then plus 4. And the final answer will be equal to 3x minus 5. Minus 5. This is very important because, like, in B, we are being asked to find the coordinates of the point R. But what is the characteristic of the point R? We are being told that this line meets the y-axis at R. It meets the y-axis at the point R. So it therefore means okay, let me just say my equation is like that. So this will be the point R, since this is a positive gradient. So at this point R, the value of x is equal to 0. Yes, because when a line cuts the y-axis, the value of x along the y-axis is always equal to 0. So my x will be equal to 0. That's what they mean. So the coordinates of the point R will be 0 something, which we have to look for. So now let us put 0 into this our equation here. Our y, let me just use what is here. From here we can get our y directly. Our y will be equal to we put 0 here, so 0 times 3, that is 0 minus 5 minus 5. So the value of y at that point will be minus 5. Therefore the coordinate of the point R will be 0, minus 5. So that's the point R. Let's move on to question 3. Question 3, given the coordinates of the vertices of triangle ABC, A 14, B 11, C 31, find the coordinates, that's the A part, find the coordinates of the vertices of the triangle A prime, B prime, C prime, obtained by rotating triangle ABC through 90 degrees anti-clockwise about the origin. About anti-clockwise and clockwise. Anti-clockwise, you go towards the right. All right, anti-clockwise left. All right, so you just hold your right hand, suspend it there, go upwards, then leftwards, downwards, rightwards, upwards again and continue to form that circle. That is anti-clockwise. So that's exactly what they want us to do in this question. So position, left, down, right, up, left, so that's anti-clockwise. Let's see how we can obtain the coordinates of A prime, B prime, C prime by rotating through 90 degrees about the origin anti-clockwise. Right. Well, in my previous videos, I actually gave a shortcut, a very shortcut that you can use to actually obtain the coordinates of this point just by calculation. We know that the rotation matrix 90 degrees anti-clockwise is given by R equals 0 minus 1 1 0. If you look at Black June and some other papers which we have presented online, we have explained this there in details. And these my points A, B, and C. I can represent them in a matrix form. A is 1 4, so I'll form a new matrix for these points. A is 1 4 1 4. The point B is 1 1, and point C is 3 1. So at this point here, if you multiply this directly, this will give us, so this is my point A, points B, and point C. When you do the multiplication of this matrix, we will have this first row times the first column. That will give us 0 times 1, that is this 0 here, times 1, giving us 0, plus minus 1 times 4, plus this minus 1 now, times 4. Minus 1, so that will give us minus 4 here. Now this first row times this second column now, times this second column, 1, 1. So this gives us 0 times 1, 0, plus minus 1 times that, minus 1. This first row again times the third column, that gives us minus 1. Then we now move to the second row. The second row now times each of those columns. So we have now 1 and 0. So 1 0 times 1 4, that will give us 1. 1 0 times 1 1, that will give us 1, and 1 0 times 3 1, that will give us 3. Therefore means our A prime, B prime, C prime, these are A prime here, these are A prime, B prime, and C prime. So our A prime is move back to black. A prime is the matrix, or having coordinates minus 4 1. B prime has coordinates minus 1 1, and C prime has coordinates minus 1 3. Minus 1 3. Actually, this can equally be done by drawing. We can actually draw this and then we rotate and see how it looks like. Let me do this second method. Many students might like this one. Just that the constraint in drawing is going to be a bit stressful. Okay, so this is my Cartesian plane. Okay, it's calibrated like this. So have 1 2. You have 1 2 3 4. This y and this is my x. All right, now let me sketch what has been given. The points A 1 as 1 4, B 1 1, C 3 1. So A is 1 4, 1 4. So this is the point A here. Then B is 1, 1. This is the point B here. And C is 3, 1. This is the point C. Now I link them. So that's what I have. Now when I rotate this by 90 degrees anti-clockwise, look at this 1, 1. Look at what happens actually. This point 1, 1 here, when you rotate by 90 degrees clockwise, it will move from this point to this point. So it will not be like that. When you rotate the point A now, the point A by 90 degrees, you find out that A will actually fall about the origin, right? So rotate A by 90 degrees, it will still maintain this 4. This is a 1, minus 2, minus 3, and minus 4, but it will now be here. So this is now my A prime. Then we rotate the point C 90 degrees, it will now be at this point you have here. So when you rotate, that's what we'll have, and this will be my point C prime, and this is B prime here. So from here you can see the coordinates clearly that is the same as the other values we had before. A prime is minus 4, 1. B prime is minus 1, 1, and C prime is at minus 1, 3. Minus 1, 3. All right, now another thing, the next question says that on a graph paper, taking 1 centimeter to represent 1 unit on both axes from -4 to 7 for the x values and from -2 to 10 for the y values, plot triangle ABC and A prime, B prime, C prime. All right, this is what we have already done even. This is good. So we have already done it according to what we have in front of us here. You can see it clearly. That's our A prime, B prime, C prime, though we have not followed the coordinates. And they're saying that taking triangle A prime, B prime, C prime to be mapped onto triangle A prime prime, B prime prime, C prime prime by a reflection on the mirror line x plus y equals 6. So I'm supposed to reflect A prime, B prime, C prime on that line x plus y equals 6 to have the triangle A prime, B prime, A prime prime, B prime prime, C prime prime. So the first thing they want me to do is to make this Cartesian plane and as well indicate that line x plus y, and then I'm going to do the reflection using that line. Okay, so I'll have to draw this thing out again because the scale that they have given me now is a bit different. So let's see what we have. I might not draw everything, but okay. Yeah, I know the line is terrible. Yeah, but so I have, let me take 2, 4, 6, 8, 10. This is y. 2, 4, 6, 8. This is my 0, minus 2, minus 2, minus 4, minus 6. 2, 4, 6, 8. 4, 6, 8. 10. Alright, so this is my Cartesian plane I have. Now I have to indicate or to sketch the line x plus y equals 6. So according to this line, when x is equal to 0, y is equal to 6. And when y is equal to 0, x will be equal to 6. So I can easily sketch this line. X plus y equals 6. So it passes at this point 6 and equally at this point 6. So can link with the my ruler. No, I'm not using a ruler as people know. So that's the line. Then this my triangle was already here, so let me just do it again. Let me just indicate it's at 4, 1 and 3. So the point is here 3. So this is my triangle. Now I have to reflect which of the triangles along that line. I have to reflect but A prime, B prime, C prime. So let me indicate my A prime, B prime, C prime again. I have this point here, then moves up to 3, and this one comes to 4. So this is it. Now from this line, since I'm to reflect this particular object, there should be mirror images. Mirror images. So from this, I know very well that this point C prime, let me indicate the point C prime, A prime, B prime. When I reflect this particular one on this line, I'm going to have these other points. I'm so expected to have something like this, that's having a shape of something like this. That's what I'm expected to have. But let's do it now. So I'll start by taking these points, and I'll take its upward distance from here, distance from this point to this line, this distance. And when I get to the line, I will move it like this. When I move it, it will fall at the point 3. So C falls at 3. That is C prime prime. Then I'll take the next point. The next point is B. I'll count the distance of B from this line. So B starts from here and B moves upwards. So when B touches this line, I'll now extend the B, the number of units. My B prime prime will be here. And now I'll equally take C and do the same. I'll take C and do the same. So for A rather, move A upwards until it touches the line, then I move it in this direction. And you find that my A prime prime will fall here. This is the point. So this is a reflection of this. This is the triangle that we obtain. And from this triangle, our A prime prime has coordinates 5, 10. B prime prime has coordinates 5, 7. And C prime prime has coordinates 3, 7. So that is it actually for question number 3. And now we can move on to look at question number 4, which is concerning this function that is represented. So question 4 concerns the function that is represented. Now just take a look at that function before I read through. Just take a look at the function before I read. So we are given this quadratic function. As you can see, it's a quadratic function, and this quadratic function is defined by f of x is equal to 5 plus 3x minus x squared. And we are being told that taking values of x from -2 to +5, -2 to +5, and using a scale of 1 centimeter to represent 1 unit on both axes, we should draw the graph of f of x. We should draw the graph of f of x. So let's see what we have. Well, my advice is that when you are given a scale like this, it's better to make a table of values. It is faster and it makes sure that you avoid errors. And if you make mistakes, you can easily troubleshoot. So table of values for x, since I've given the values from -2 to +5. So from -2 to +5, -2, -1, 0, 1, 2, 3, 4, 5. I'll now take this my function which has been given to me, and I'll break it into 3 parts. And this is what I'm going to do. Oh, okay, let me. Okay, let me take the function again. Sorry, I cleaned the bot instead. So we have x -2 -1 0 1 2 3 4 and 5. So I'll take this function and divide it into 2 parts. So the first part of that my function is the constant 5. The second part of it is the term 3x, and the third part of it is the minus x squared. So I partition this my table, and here my y values will enter. Now let us start filling these values in. Since this 5 is a constant, I'll just copy it all through. Because it's not a function of x. Now the next thing is 3x. So each x value I have, I should multiply it by 3. So -2 times 3, -6, -1 times 3, -3, 0, 3, 6, 9, 12. And how many do you have here? 15, of course. Yeah, 15. Then the last one, I will take each of the x values, square them, and multiply it by the negative. So I have -2 squared is 4 times the negative sign in front, -4. -1 squared is 1 times negative, or times minus whatever. -1, 0, -1, -4, -9, -16, -25. So this will now give me my y values when I sum. So my y values when I add, I have 5 plus -6 plus -4. That gives me -5. Here gives us a 1. Here 5. 7, 7, 5, 1, and -5. Now from here, if you look very well, you see that this is symmetrical, and if there is a mistake, you will see. For example, look at this, 7 and 7. And then moving away, you have 5 and 5. Moving further away, you have that, and at the ends, you have -5 and -5. And since the coefficient of our x squared is negative, we expect that if we sketch a graph of this function, it is going to have this shape. It's going to have the shape of a hill. Right? It's going to have that shape. So now B, they're saying that, okay, still in A. Let us now do the graph. We have finished making the table of values. We now move to the graph and see how we obtain it. Now, but we have to first of all look at this table. Look at the range of our x values. X ranges from -2 to 5. So our graph will be around that interval with respect to the x-axis. And then the y value, the smallest y value is -5, and the biggest value is 7. So we can make our graph to be around the interval of -6 and +8, just slightly above, so that we know exactly how to position it. Okay, so and then so here have my 0 blocking. 0, 2, 4, 6, -2, -4. -2, -4, -6. Okay. -6, -4. Then here you have a 2, 4, 6, 8. This is my y-axis and this is my x-axis. So the first point is the point from that table that you have. When x is -2, y is -5. X is -2, y is -5. So we have this point. Let me make it in red. The next point, when x is -1, y is 1. X is -1, y is 1. So you have this point. When x is 0, y is 5. X is 0, y is 5 here. When x is 1, y is 7. X is 1, y is 7. Here. Y is 2. When x is 2, y is 7. X 2, y is 7. Here. X is 3, y is 5. Here. And when x is 4, it is 1. Here. And when it is 5, it is -5. So we have this point. So we can now link with a smooth curve. These are points. And that is the curve of the function y equals f of x. F of x, that's a function, the curve of it. Now, we are being told that using your graph, determine the value of x for which 5 plus 3x minus x squared equals 0. 5 plus x minus x squared equals 0. So normally this is the equation that we have been solving. So from our graph, we can actually see these values. Normally, when you use the graph paper, you see the values clearer than I have. But from here, you can state the values. And how do I see the values from my table? On what you have, where it cuts the x-axis, what's the x value at that point? The x value at that point, like here, you can look at the x value at this point. Like here. And another x value at this point. So this will give us the following values for x. For x, we will have x equals minus 1.5, and then another one. You can estimate. Some people have minus 1.6, some people have minus 1.4. It's okay. Normally they give a marking allowance. X is equal to 4.5. Some people may not have 4.5, they may have 4.4, some may have 4.6, slightly different, but the difference will not be that much. Okay. And then now we are being asked to find the gradient of the curve at the points where it cuts the y-axis. So they want us to find the gradient of this curve at this point here, where it cuts the y-axis. So we are going to make a tangent at that point, a tangent like this. Then we get the change in y and change in x from there. So this is a triangle we have formed, and from this triangle you get the x value here and the x value at this point. To get the change in x values, look at this point and this point. change in x. From there, you can get a change in x directly. A change in x will be equal to 2 minus minus 2. The value of x here is 2. Here is minus 2. Minus minus 2. That gives us 4. And change in y. Change in y will be equal to 9 minus 1. This value that is here, 9 here, and then minus 1. So 9 minus 1, giving us a value of 8. And our gradient is given by change in y divided by change in x. That's how we calculate gradient. So change in y divided by change in x will give us that is 8 divided by 4, which is 2. So our gradient m will be equal to 2 when you calculate change in y divided by change in x. Okay. All right, the B part of the question reads, that's the last part of this question. P and Q have position vectors 3, 2 and minus 1, 2 respectively. If OP is equal to 3 OQ plus 2 OR, find OR in terms of I and J. This question on vectors, and they've given us the relationship. Normally we know OP and we equally know OQ, so we can now look for 2 OR using that relationship directly. So this will give us we have OP will be equal to 3 OQ use it this way. Plus 2 OR. Remember to put the signs. So we are looking for 2 OR. But we know the value of OP and OQ. So this will be our OP is 3, 2. The matrix form 3, 2 be equal to 3 times OQ. OQ is minus 1, 2 plus 2 OR. So when you solve for this equation, you have 3, 2 minus 3, 6 be equal to our 2 OR that we are looking for. So finally 2 OR be equal to, when you finish solving in terms of I and J as the equation is saying, will give us a value of 6, 2 minus 6 minus 4. So that's a 2 OR. And that's if you find the position vector of R, well, if 2 OR is equal to this, then OR should be a half of this, which is 3, 2. And the position vector of R is OR equals 3 I's plus 2 J's. Thank you guys so much, and stay tuned as we upload other papers. Visit our blog for more materials, and equally take part in our end of month awards. This award is written online, and you have a cash prize that is sent to you if you win. Just get to our blog to get more information. GCE Math Panel Awards. You can equally follow us on Facebook every Sundays to see our program, GCE Math Panel. And don't forget to follow us on our blog. to share this and to get papers and other material. Thank you so much, and bye bye. I'm your host, Dr. Miles.